Welcome to Sundar's lecture. This is lecture number 85, and in this lecture we are going to start a new topic, that is two-port network, right? So what is two-port network, and what are all the insights in two-port network, and how we are going to solve these kind of network? The whole idea about two-port network we will see in the future lectures, right? But today what we are trying to learn, see, if I have any RLC circuit, maybe you see this is resistance and an inductance is there, and there will be a capacitance. Until now what we have seen, that is what I am just going to explain you now. See, a circuit is like this, and what we are going to do, we are going to excite this circuit, maybe AC or DC, anything it may be, anything. So this is V as an input, and this is the resistance value, and this is inductance, and this is capacitance, and we are exciting with the voltage V, and we are going to find what is I. That's all, right? This is what we have seen until now, and these kind of circuits we can call this as single port network. Since we have single V and a single I, we need to find the current with the excitation of voltage, right? That is what we have seen until now. But what is the topic today? It is two port network. We have two inputs, we have a one input port and one output port. That is what we are going to see. See, I will draw the diagram. Anyhow, I'm not going to hide the drawing diagram. See, this is the two port circuit. I'm not showing you the exact circuit. I have just drawn the diagram. This is two port network, two port network, right? So here what we will have, this is the input, this is the input, and this is the output. See what I am going to do, this is plus minus V1 and this is plus minus V2. And what is the current here, that is in this direction, that is I am going to take it as I1. And see, this current, I am just taking the direction, this is I2, this is I2. See, try to understand, these are all, I am going to show you what is Z parameter, Y parameter and hybrid parameter, all those kind of things will come under the two port network. And also we are going to see ABCD parameters, which we are going to apply in transmission networks. And that condition on those ABCD parameters, I will change this current direction. See, we already seen the current directions, whatever the directions we are taking, it is up to us what is the direction we are taking, right? So it is my wish to take the current direction, and I have taken the current direction in this way, that is I2. See, what is a two port network? In this network, you should not have any source, obvious, for an obvious reason, you should not have any source inside this network. That is the only case. But you can have the impedances, maybe reactances may be available, inductive reactances, capacitive reactances, resistances, whatever it may be, we will call commonly it as the impedance values, right? So for example, let it be, for example, it may be, it may be, it may be like this, right? The common point, this is plus, this is plus, minus V2, this is I2, and this is plus minus V1, and this is I1. And what is the two port network? This is nothing but we are calling the parameters inside the two port network. Maybe this is EZ1, EZ2, EZ3, whatever it may be, whatever it may be. It is not it should not be the exactly the same circuit whatever I have drawn here. It may be a different circuit. Maybe you should have two input, two ports, one is input and one should be the output port. That is the idea you have to understand, right? What I am going to do, I am just going to derive the voltage value in terms of current now. How can I do that? See, I will write down the expression, then I will try to explain you. See, V1 can be related to current I1 plus current I2. Current I2. And how that can be related? It can be Z11 and it can be Z12. And V2 that can be also related to I1 as well as I2. And how this can be related now? Z21 and Z22. For example, you try to understand certain things. Maybe you can write this in the matrix format too. So what it will be? This is V1 and this is V2 in matrix. That should be is equal to Z11, Z12, Z21, Z22, and this whole expression will be multiplied by I1 and it should be I2. See, this is what the relationship we can do. So this is what we have seen already, right? In the inspection method, try to, if you have any doubts, please see my previous lectures, and we have written the expressions like this. For example, what is it for this circuit? For this circuit, maybe this circuit is number one. Example number one circuit. What will be the Z11 value? What will be the Z11 value? It is Z1 plus Z2. It is Z1 plus Z2. See, this is the first loop. What is the total resistance? It is Z1 plus Z2. And if you are going for Z12, what is the value of Z12? It is minus Z2. That should be the Z2 value. And Z21, the same value. And what is Z22? What is Z22? And it has to be Z2 plus Z3. That's all, right? You can simply get the values. If you know the inspection method, you can easily relate this V1 and V2 in terms of currents with a parameter called Z parameter. And this matrix, which is nothing but, we are calling it as Z parameters. Z parameter. That's all, right? That's all, very simple, right? If you want to find what is the value of Z11, Z12, 21, 22, there is a procedure, and that is what we are going to see now. And you see, I have just taken, this is the two-port network, right? Two-port network, TPN, V1 I1, V2 I2, and if you want to find how the Z parameters, then what you have to do with this circuit, right? In this particular two-port network, it should be source-free network, and you can have any impedance as well. You keep that in mind. I will repeat it again and again because you have to understand those kind of things, right? First to find Z11 and Z21. What you have to do? See, you just open circuit this secondary, maybe the output port, and you excite the input port. So how will you do that? See, this is the two-port network. And you are just going to open circuit this one. I am not going to touch this one, right? And I am going to excite this network. So if I excite, what I will get? This is V1 and I1 should flow, and this I2 will be now 0, and this is V2. You can measure, right? If you apply V1, then I1 you can measure by using the meters or anything, and V2 can be also measured. And if you are open circuiting this one, the I2 will become 0, right? That is the whole idea you have to understand. So what you can do now, you just apply in this network. So V1 should be is equal to Z11 I1 will be there, and this term becomes 0 because I2 is 0, right? I have just open circuited the secondary, the output port, open circuit output port, right? That is what we have done now. So this will be the equation now. Then what will be Z1? Z11 will be V1 by I1 with respect to I2 should be is equal to what? 0. Which means this is actually means output port output port is open circuited. Output port is open circuited, and maybe this is expression number 1 and this is expression number 2. This we have got from 1, and if you are going for the expression number 2, from 2 what you can write down the expression. So this becomes 0 because I2 is 0. So V2 should be is equal to Z21 and I1. And finally what you can write, so Z21 can be written as V2 by I1 in the applicable restriction is I2 should become 0. So this is open circuited output port. So what you are getting here, if you open circuit this output port and you excite this input port with some voltage, then you can easily find, and this can be measured. V1 you know, it is very easy. Put an ammeter here, you can easily get what is the value of I1, and you put a voltmeter here, you will get V2. So all the values now it is known to you. So what you can do, you can easily find Z11 and Z21. Then the next step may be to find Z12 and Z22. This is the next step. What you can do now? Simple. You excite the output port and you just open circuit the input port. Open circuit the input port. See, the diagram will be now. This is the two-port network. Two-port network. This is two-port network. What you do? You excite with some voltage, that is V2, so that there will be current. See, I am taking current in this direction. Try to understand. You have to take current in this particular direction. Don't change the current direction, and you will not get the answers if you are changing the current direction, right? So this will be now V1 and this will be now I1. Since this port is open, this is two-port network. Since this is now open circuited, then I1 should be equal to 0. So if I1 is equal to 0, then you can get this expression. I will take it to the next page. Say I have just taken the expression. So from expression 1, what we will get, this I1 has become now 0. So what will be the expression now? So V1 should be is equal to Z12 and I2, right? So from here it is simple to write down the expression that V1 by I2 with respect to the input port is open circuited. Here input port is open circuited, and very simply now it is very easy to understand. From 2 this expression becomes 0. So V2 can be written as Z22 and I2. So finally what you can write, so Z22 can be written as V2 by I2, and the condition is simple that I1 should be equal to 0. So the input port here also open circuited. See, now we got Z11 and Z22. All the parameters we have got it right. So Z11, Z12, Z21 and Z22. All the parameters we have got with two different circuit combinations. With input port is open circuited, we will get Z21 and Z22. With the output port is open circuited, we will get Z11 and Z21, right? Both the values we have got, right? This is nothing but we are calling it as EZ parameter. This whole network we are calling it as EZ parameter, right? Now one can tell me that, see, this is what is Z parameter, so I will write it now. Z matrix can be written as what? Is it Z11, Z12, Z21 and Z22, right? Now this is called Z parameter, and we know how to find the values of Z11, 12, 12, right? Now one can tell me that you can always write the expression in terms of current. Now what we have done in the first case, we have written the expression with the voltage expression with respect to current. Now one can tell me, right, you just write the current expression with respect to voltage. That is also possible, right? That is what we have seen it as nodal voltage analysis method in our previous lectures, right? So we will take this two-port network and we will go to the next page. Maybe this is EZ parameter. EZ parameter, right? This is called EZ parameter. Now we will go for Y parameter. I will take it to the new page, right? I have taken the diagram and now we are going to find what is the Y parameter. So how will you find the Y parameter now? You have to write the expression in terms of current now. So I1, just I will write it down and then I will explain you in terms of V1 plus V2. What will be the expression? It has to be admittance Y11 and it will be Y12, and I need to write what is the expression of I2, and I2, what I can write it down, I have to write it in terms of V1 and V2. What it will be? It will be Y21 and Y22. And I have already told you, right, if your circuit is like this, the impedances are like this. This is the Z1 or Z2, it may be Z3. So what will be the expression? See, if I want to write this in the matrix format, this is I1 and this will be I2, and this has to be written as Y11, Y12, Y21, Y22, Y22, and this will be now multiplied by V1 and V2, right? What will be your Y11? Y11, the value is the inverse one, right? Y11 should be what? It will be the two-port network. Maybe if the circuit, maybe I will take a different one so that you can easily understand. So if you are I will take a different one. See like this. If it is like this, this connection is there, and also this connection is there. So if this is the port number 1, this is node number 1 and this is node number 2, Y11 will be what? Maybe if this is EZ1, if this is EZ2, if this is EZ3, then what will be Y11? So Y11 will be is equal to 1 by EZ1 plus 1 by EZ2. It is possible, right? Then what will be Y21 or Y12, maybe anything, Y12, it will be minus 1 by Z2. So like that you can write down the expression. You please refer my inspection method of getting the nodal voltage analysis equations. You can easily understand these kind of things, right? So now this is the expression. Now if I need to find what is the value of Y11, 12, 21, 22, then you have to follow certain procedure, right? What will be that one? We will see that. So now to find Y11 and and Y21, right? How will you find? So this is the two port network, right? I will draw this. This is now our two port network, and if you short circuit this one, the output port, what happens? And you just excite the first port, right? This is V1 now, and this current will be I1 now, and this current will be I2. This is two port network. And what happens to V2 here? V2 becomes 0 since we have short circuited. The potential difference between these 2 points becomes 0. So if this is expression number 1 and if this is expression number 2, uh, what I will get? So from 1 I will directly write down the expression, and I'm not going to write an extra expression. So if V2 becomes 0, then what will be Y11? It will be Y11 should be is equal to I1 by V1 with V2 is 0, which means you are just short circuiting the output port. That's all, right? Simple output port. So this is one thing. And now from expression 2, what you will get? So if V2 becomes 0, then you can easily find Y21, and that should be is equal to I2 divided by V1. And here also the condition, it is short circuiting the output port. Right now we have found what is Y11 and Y22. Sorry, Y21. And if you want to find what is the value of Y22 and Y12, simply I'm not going to draw the diagram, so you try to understand. Anyhow I will draw it down. So to find Y22 and Y12, what you do? You just take down this two port network, and you just excite this secondary, which means the um, output port with some voltage, and the current I am taking in this direction, and you try to short circuit the first port, which means V1, here V1 becomes 0, and you have this is I2, this is I2, and this is now I1. This is two port network. And from one expression, very simply, from expression number 1, so from 1 what happens now? V1 becomes 0, so V2 will be Y12 will be is equal to what? V2 I1 by V2. So Y12 will be is equal to I1 by V2, where V1 should be is equal to 0. Here the condition is short circuit the input port. Short circuit the input port. And likewise from expression number 2, and you can easily see that Y22 should be is equal to, this is 0, Y2 by V2, I2 by I2 by V2. With respect to V1 should be 0, and the condition is short circuiting input port. Right now we have found what is the Y parameter, right? What is Y parameter? So Y parameter will be is equal to Y11, Y12, Y21 and Y22, right? Now this is the Y parameter for two port network. With this convention, this is I1, V1 plus minus V2, I2, and whatever it may be inside the two port network, you should have source free network. That is the only condition. So now we can write the expression like this one, right? V1, V2 should be. If you are writing like this, then you can easily write this is Z11, Z12, Z21, Z22 and into I1, I2, I1, I2. And also you can write the same network. I'm just taking the same network. Try to understand the same two port network. This is I1, I2, right? This can be written as Y11, Y12, Y21, Y22, and this value will be V1 and V2. See, one thing you try to understand, this is that if you are bringing it to the other side, then this is I2, right? This is I2. If this Z parameter is brought to the other side, then you can easily relate that this Z11, Z12 and Z21, Z22, which is nothing but Y11, Y12, Y21, Y22, the inverse. Possible, right? If you bring this to the other side, then the inverse of this one, which is nothing but this expression. And if you bring this to other side, then the inverse of this one, which is nothing but this expression, it is nothing but the inverse matrix. Will this is possible? And will this can exit? And what are the condition for this Z parameter can be equated to the Y parameter inverse? And if there cannot be, you cannot say that in all the condition this inverse matrix will give you, this inverse of Y matrix will give you Z. No, it is not possible, and it cannot be done also, because there are certain rules where inverse can become infinity value. So that we will see in the next class. So what are the topics we have seen today? See, we have seen what is two-port network. We have just taken and we have just explained what is the two-port network. And in two-port network, we have seen what is the Z parameter and how to find the Z parameter values by open circuiting these the output port and input port. We have found what is the Z parameter values, and also we have seen Y parameter. And how will you get the Y parameter values? You have to short circuit the output port, and then also you have to short circuit the input port to find the values of Z parameters. And we have concluded that Z parameter can be the inverse of Y parameter and Y parameter can be the inverse of Z parameter. But there are some restrictions, and in some circuits you cannot exactly say that this Z parameter can be the inverse of Y parameter or Y parameter can be the inverse of Z parameter. Try to understand those kind of things, and you just go through all these things. We will see in the next class with what are all the conditions that has to be satisfied if these two matrices should be inversely equal, right? That we will see in the next class. Thank you.